So hello everyone, in this video we are going to look at some reverse questions regarding Poisson distribution. So the first question, it states that the yearly number of earthquakes in a city follows a Poisson distribution with mean m. So here the mean is unknown, and it is given that the probability of having at least one earthquake in a year is 0.0756, and we need to find m. So we can say that the x, suppose x follows the number of earthquakes in the city, so x will basically follows a Poisson distribution with mean m, and then it is given that the probability of having at least one earthquake, so x greater than equal to 1, it is equal to 0.0756, and then we need to find m. So basically this is equal to 1 minus probability x less than 1 is equal to 0.0756, and then probability x less than 1 will be equal to 1 minus 0.0756, which is equal to 0.9244. Now we need to solve probability x less than 1 is what? Probability x less than 1 is basically probability x equal to 0. So this is equal to e power minus lambda, which is m in this case, and multiplied by m power 0 over 0 factorial, and this is equal to 0.9244. Now we need to solve this. So e power minus m is equal to 0.9244, because this is basically 1, and then minus m will be equal to ln 0.9244, and then minus m will be equal to minus 0.0786, and then m is equal to 0.0786. Therefore the mean is 0.0786. Okay, so the next question is a past paper. It is June 16, paper 72, and question number 6. So this question is about hair dryers, and it is a very important question because you have to understand the question very carefully. So let's read it. So at a certain shop, the demand for hair dryers has a Poisson distribution with mean 3.4 per week. So in 1 week the mean is fixed and is 3.4. Find the probability that in a randomly chosen 2-week period the demand is exactly 5 hair dryers. So suppose x is the demand for hair dryers in that week, and then we need to find for 2-week period the probability that the demand is exactly 5. So in that case, so for 1 week, so lambda here would be equal to 2 times 3.4, which is equal to 6.8. Okay, so and then we can say that x will follow a Poisson distribution of 6.8, and basically we need to find probability x equal to 5, and then, so we can do it here itself. So probability x equal to 5 is pretty simple. It is equal to e power minus lambda, which is 6.8 multiplied by 6.8 power 5 over 5 factorial, and this is equal to 0.135. Okay, so now for part 2. At the beginning of a week, the shop has a certain number of hair dryers for sale. Find the probability that the shop has enough hair dryers to satisfy the demand for the week. So now we are talking for 1 week only. So lambda is back to 3.4. and there is no scaling required here. Here we scaled up, and here we do not require to scale the mean. So to be able to satisfy the demand, so if they have 4 hair dryers, the demand should be less than 4 to be able to satisfy the demand. And so we need to find the probability that the demand, which is x, is less than or equal to 4, and then the shop will be able to satisfy the demand. And here we need to solve for probability x less than equal to 5. Same reasoning here for these two parts. So let's do probability x less than equal to 4. But here x follows a Poisson distribution of 3.4. So let's solve this. So this is equal to e power minus lambda, which is 3.4. So it's minus here. Let me just make it more clear. So this is minus 3.4. Then we take out the common. So this is basically 0, 1, 2, 3, and 4. So this is what? So 3.4 power 0 over 0 factorial plus 3.4 power 1 over 1 factorial plus 3.4 squared over 2 factorial, and then 3.4 cubed over 3 factorial. And then you can type this in your calculator, and the answer is 0.744. Now for part B, they have 5 hair dryers in the shop, so the demand should be less than or equal to 5 to be able to satisfy the demand. So let's solve part B. Part B is probability x less than equal to 5. So here we only need probability, so this is equal to probability x equal to 0, 1, 2, 3, 4, 5. But we already have probability x less than equal to 4. This part here, this part we already have. So we only need to say that this is equal to probability x less than equal to 4 plus the additional 5, probability x equal to 5. So this is equal to basically the previous answer plus probability x equal to 5, which is e power minus lambda multiplied by 3.4 power 5 over 5 factorial, and this is equal to 0.744 plus typing this in your calculator is 0.126, and this is equal to 0.870, and this is your answer for part B. Now moving on to part C, we need to find the smallest number of hair dryers that the shop needs to have at the beginning of a week, so that the probability of being able to satisfy the demand that week is at least 0.9. So basically we need to find the number of hair dryers so that the shop owner is 90% sure that he will satisfy the demand. So basically, if the shop owner has X demand, the number of hair dryers should be greater than that. So basically the demand which is X should be less than equal to N. So for example, if the number of hair dryers is N, so the demand should be less than equal to N, and then we need to find N so that the shop owner is 90% sure he or she will satisfy the demand. So basically we need to find probability, and it says it at least 90%, so at least 0.9. So basically we need to solve N here in this case. So let's solve this for part 3 of the question. So we need to solve probability x less than equal to N greater than equal to 0.9. So basically we can use trial and error. So let's say n is equal to 5, because we already find probability x less than or equal to 5. And again here we are talking for a week, so lambda is still 3.4. okay, so now we need to solve for n. So we can use trial and error. So when n is equal to 5, we can say probability x less than or equal to 5. So we don't need to calculate this, we already have the answer in the previous part, which is equal to 0.870. However, this is less than 0.9. We want it to be greater than or equal to 0.9. So let's try n is equal to 6. So let's try probability. Let's try n is equal to 6. So we need to find probability x less than or equal to 6, and this is equal to probability x less than or equal to 5 plus probability x equal to 6. Same logic as above here. Same logic as here. So this is equal to what? 0.870 plus probability x equal to 6, which is e power minus lambda, multiplied by lambda power 6 divided by 6 factorial, and this is equal to 0.80 plus 0.0716, and this is equal to 0.9426. So 0.9426, and this is indeed above 0.9. So we can say that the smallest number of hair dryers required to be able to satisfy the demand, such that the probability of satisfying the demand is greater than or equal to 0.9. We need to have 6 hair dryers, therefore n is equal to 6. So therefore 6 hair dryers. So this two question is very important because it is the reverse process. We are not just calculating the probability as here. We need to find some unknowns. For this part we needed to find n. And for this question here we needed to find lambda. So this is it for this video. This two question is really important for your exam. So thank you for watching.